It's about colligative properties. The calculations that we can do with these in this class for honors will be freezing point depression and boiling point elevation. So all of the formulas that you will need will either be physically written on the test or they'll be on your formula sheet. You just need to know how to look through your formula sheet. There's lots of different types of questions that you can have, but as long as you know how to manipulate an equation and to know what you're looking for, you really should be able to figure it out. Okay, so this first one says, what is the freezing point of 325 grams of an aqueous solution containing 15.85 grams of NaCl with the Kf value, of 1.86 degrees Celsius per m. So I'm going to go ahead, I'm going to underline all the numbers that they gave me because that's going to be important later. Okay, we know that the freezing point of your solution equals your original freezing point of your solvent minus your delta TF. We learned that delta TF is equal to Kf, which is just a constant, times our molality times I, which is just the number of particles. And then we also learned that molality equals our moles of solute over kilograms of solvent. So generally speaking, when you're doing problems like this, you got to be able to find your molality. So that's the first thing we're going to do right here. So step one, we're going to find our molality. So molality is going to equal the moles of our solute, which was NaCl, over the grams, or the kilograms of our solvent. So first thing I need to do is convert this guy right here, grams to moles. So I'm just going to do it over here in the corner. I'm going to say 15.85 grams. I'm going to divide by the molar mass of NaCl, which is 58.44. When I plug that into my calculator, I get 0.27 moles. And then I'm going to go ahead and change these grams of my solution down to kilograms because I have to. And this ends up equaling 0.27 divided by 0.325. It ends up equaling a molality of 0.83. Okay, so I'm going to be able to plug that in later. So now I can go ahead and find my delta TF. So my second step is to find delta TF. So I'm going to say delta TF, and that is really just the change in the temperature that we're having when we're adding this solute to our solvent. So I'm going to go ahead and plug in my Kf value. It will be given to you. Okay, we know that our Kf is water's Kf because aqueous means that it's dissolved in water. So that value for water is always going to be 1.86 degrees Celsius per molal. And I'm going to multiply by my molarity, so that's 0.83 molal. And then I'm going to multiply by my I value. So if you have a covalent bond, if it's two nonmetals together, your I value is going to equal 1. If you have an ionic compound, though, however many ions you have within that formula, that tells you what your I value is. So in this case, we know that NaCl really splits into Na plus and Cl minus. So that's 1, 2 for our I value. And now I can go ahead and solve for my delta TF. So I'm going to plug this in. I'm going to say 1.86 times 0.83 times 2. And that ends up equaling a delta TF of 3.09-ish degrees Celsius. So now that I have my delta TF, and I know the freezing point of water is 0 degrees Celsius, I can go ahead and plug it in to find my new freezing point. So my new freezing point is going to equal my original freezing point, which was 0 degrees Celsius, minus my delta TF, which was 3.09 degrees Celsius. This ends up equaling negative 3.09 degrees Celsius. And this should make sense to us because we know that freezing point depression happens. So our freezing point should get lower. Lower than 0 is going to be a negative number. So that's one type of problem. Here's another one. We can do something very similar, but this time it's with boiling point. So once again, we're going to underline all the numbers they give us because that's probably going to be important. We know that to find the boiling point of your solution, you have to do the boiling point of your solvent plus your delta TB. We know that delta TB is equal to KB times m times I. And we know that our molality equals our moles divided by our kilograms. So once again, I probably need to find my molality because that's what we need for these colligative properties problems. So in this case, we need to find moles of our MgBr2 because that's our solute. So I'm going to go ahead and say 63.5 grams. And I need to take a second to look at my periodic table because I forgot to write down what the molar mass of MgBr2 is. So just give me a second. Google's telling me it's 184, so if it's not, I'm sorry. So I'm going to go ahead, I'm going to divide that mass by the molar mass that Google just told me. And I get a molality, or I get moles, oh my gosh, sorry, about 0.345 moles. So I'm going to plug that in to my molality equation. It's going to be 0.345 moles. Then I'm going to divide it by kilograms. Once again, I can move 3 spaces over. This becomes 0.125 kilograms. And so then I can say 0.345 divided by 0.125. That equals 2.76 molal. Now I can go ahead and find my delta TB. So the KB for water is 0.512. Again, I'm using water's value because it told me that it was aqueous. I'm going to multiply by molality, which is 2.76. And finally, I'm going to multiply by my I value. First thing I need to ask myself, is this an ionic or covalent compound? This is an ionic bond because we have magnesium, which is a metal, and bromines, which are nonmetals. I have 1 Mg right here, and it has a 2 plus charge. And I have 2 bromines, canceling out that charge, which means I have 1, 2, 3 particles. So my I value is going to be 3. I'm going to go ahead, I'm just going to multiply all these guys in my calculator. 0.512 times 2.76 times 3. And that ends up equaling a delta TB of 4.24 degrees Celsius. Now I can go ahead and plug all of this into my boiling point equation. So I'm going to say, okay, the original boiling point of water is 100 degrees Celsius. I'm going to add my delta TB to that, which is 4.24 degrees Celsius. And we end up learning that if we dissolve that much magnesium bromide, we end up changing our boiling point from 100 degrees Celsius all the way up to 104.24 degrees Celsius.